Hello everyone. In this short presentation, we are going to see how cybersecurity is a key driver for Industry 4.0. Nowadays, we are immersed in the fourth industrial revolution, the so-called Industry 4.0, which converts factories in smart autonomous systems with incorporation of Internet of Things or IoT devices and sensors, digitalization, and big data. As we can see in the picture, for Industry 4.0 to provide benefits, it's needed some management system fed with information from a big data system. All this information is transmitted through a network that interconnects sensors and devices. Once this information is collected, it's stored and processed to take some decision that influence performance of the whole system. Then, key elements of Industry 4.0 are IoT devices and hyperconnectivity of systems. This involves a huge challenge because an environment that has been isolated for years now is connected locally and to internet to provide more control and automatization of tasks. Due to this loss of isolation, a more connected system entails new domains to explore by malicious attackers that would gain profit damaging production systems. From the point of view of interconnectivity and networked systems to understand cybersecurity value, it's needed to consider that we can see Industry 4.0 as a combination of cyber-physical systems and IoT elements. We can define a cyber-physical system as an integration of sensing, computation, control, and networking into physical objects and infrastructure, connecting them to the internet and to each other, and IoT elements as those devices that interface with the industrial environment to catch information to be processed and launch actions to be implemented. In fact, for Industry 4.0, we can redefine this concept as industrial IoT, which deals with connectivity for smart factories, machines, management systems, and more to streamline business operations. Referring to cyber-physical system, we can see the physical domain, formed by sensors and actuators, and the cyber domain, formed by communication, storage, and computing. Each of these components has a bunch of vulnerabilities that must be addressed because they can be exploited to threaten both physical and cyber domains. As we can see on the right, the threats to cyber-physical system are multiple, so new attack options arise through the interconnected system, previously used to be isolated and barely protected. The complexity of secure cyber-physical system design is relatively manageable if one concentrates on one particular application scenario or use case, but it is a hard task and difficult to accomplish complying all security requirements. For industrial IoT environment, we have to consider technology elements which are needed to connect and analyze data from machines and equipment, including hardware such as chips, sensors, or gateways, connectivity protocols and services, software components such as infrastructure, IoT platforms, and analytics, and applications that are built on top of the software layer. We also have to consider disrupted technologies that arise with technology evolution and will replace the old standards and protocols. So, the proliferation of different devices, networks, technologies, platforms, and applications to support IoT multiplies the vulnerabilities and greatly increases the potential for malicious attacks. In the picture, we can see the top 10 IoT vulnerabilities according to OS project, but they only represent the tip of the iceberg. Since in the IoT environment there are different sectors, multiple devices and networks, several IoT platforms and cloud computing and big data systems, threats can come from many different levels and fronts. It's a massive jigsaw, and every piece has to deliver a level of trust to ensure end-to-end security and integrity of the system. And here come up the problem. There is no joined-up approach to implement cybersecurity to the whole system. Manufacturing industry is one of the most vulnerable industry to cyber attacks. A security breach in a manufacturing system may suppose compromising intellectual property, supply chain, or even a problem for a country or nation state, if this manufacturing system provides services for the public sector. As we can see in the high-level reference model on the left, and as we have described earlier in the presentation, a lot of components exist for Industry 4.0 and smart manufacturing, from primary hardware to industrial control systems and their networks and components, and also artificial intelligence and machine learning, which sometimes are conducted in the cloud. Then, we have a lot of assets to watch for and protect, and a large list of security challenges to deal with. After an analysis performed to the most relevant assets in Industry 4.0 and the threats that affect them, we can conclude that there is a lot of work to do for protecting a smart manufacturing sector and Industry 4.0. In the table are shown these assets and the threats classified by type. Considering those assets that are affected by more threats, industrial IoT devices, industrial control systems and their communication, and the information in transit through the network and stored in the system, these are the most critical assets to be protected. Which does not mean that you don't have to consider the rest of assets. All the environment must be secure. And do not forget, in addition to threats related to IoT technologies, Industry 4.0 and smart manufacturing companies are likely to be affected by additional threats, which are typical in operational and information technology environments. Finally, in the report of ENISA shown in the slide, you can find guidelines and recommendations for operators, manufacturers, and users of industrial IoT that, if applied, can help prevent or properly respond to potential cyber attacks and ensure overall security and safety of the industrial IoT environment. There is not a unique approach to deal with cybersecurity for these types of environments, but these good practices help to perform a good design, management, operation, and control for the whole system. And that was all about cybersecurity in Industry 4.0. Thank you for your time.